Hello everybody. Today, as I have discussed in my previous class some of the questions, and today I have bring some more questions for you. Okay. Now suppose this is a given. Okay. This is question number one. Actually, this question is first I will write the question, that is, find the equivalent resistance of the given circuit. Okay, this is point A, and this is another resistance. This is also a resistance, and this is connected in this way, and here is one more resistance. This is also a resistance, and this is also a resistance, and this is your point B, and you have to find the equivalent resistance of this given circuit between the point A and point B. The value of resistance in the given circuit, all are of our own resistance, all are in are of our own resistance. Okay. Yes, now as I have told you that yesterday in my previous lecture, I have told you that if that you know the concept of Wheatstone bridge, and in this figure, look, this is point A, and this is connected in this way. The upper part and the lower part both are of symmetrical type. Okay, so if you fold from the upper side, this is your point, suppose D, and you are folding from the D point to C point, आपने उसको fold कर दिया. Okay, when you will fold, then this R and this R both will come in parallel to each other. Okay, so you will redraw the figure, then it will appear like this. Okay, this is R, this is R, this is R, this is R, and R, point A, point B, and this all are in parallel. This is parallel, this is also parallel, and this is also parallel, because you know that R into R upon R plus R, this is equal to R square upon 2R. This R got cancelled, and this is value R by 2. Okay, so I have written R by 2 for this and this. Okay, now using the concept of Wheatstone bridge, and again we will redraw the circuit in such a way. This is of R ohm, this is again R, this is R by 2, this is R by 2. Okay, this is your point B, this is your point A. Now this R by 2 is removed, because in case of Wheatstone bridge, as you know that, suppose this is your this circuit, and this is point A, B, C, and D. When potential of B is equal to potential of D, then no current will flow through this ohm, and galvanometer show zero deflection. Okay, same situation like that appear in this circuit. So we have removed this arm, and we have redraw this circuit. This is point A again. As you know, this R ohm and this R ohm both are in series connection. So what is the equivalent of these two? This is R plus R, that is equal to 2R. Okay, and this is R by 2, this one R by 2, and this one R by 2. Okay, both are in again series, so we will combine. We can write like this for this arm, like this, R by 2 into R by 2. Okay, and after solving, you will get r by 2 plus r by 2, r by 2 plus r by 2, this is equal to, you will get equal to 2r upon 2, and this is equal to what, r. So this one become of r. This is your point B. Now on solving this circuit, you will get 2r into r upon r plus 2r. This is equal to 2r square upon 3r, and this square got cancelled, and this is equal to 2 upon 3 of r. This is your equivalent resistance between A and B. This is your answer. Now we will proceed and see the next question. Again, you have given a such type of network. Find the equivalent resistance of the given circuit. Note down the question. Find the equivalent resistance of the given circuit. Solution. Note down. Suppose this is a given network. This is of, this is a resistance. Now this is your point A, and this is your point B. Here also a one more resistance. Suppose one resistance is connected like this, and one more resistance is connected here. Okay, this is your of, this is of 4 ohm, this is of 6 ohm resistance, this is 2 ohm, and this is of 8 ohm. Okay, now as I have told you in earlier classes that once you have to find the equivalent resistance between the point A and B, you have to redraw the circuit as simpler, so that you would be able to make the combination simpler. Okay, now as I have told you about the steps, a point I have taken here, and I am proceeding towards the 4 ohm resistance, and I have mentioned here this point as a C. Okay, and when there is no resistance is connected in between any other point, then you have to mark the same name here also. Okay, now you have to find R equivalent between A and B. Okay, write A and B at the extremes ends. Okay, and this is your point C. Okay, when you will see, when you will move from point A, you will find that here is a 4 ohm resistance between A and C. So this is a 4 ohm resistance between A and C. Now you have again moved to A, and you have seen that this 2 ohm resistance is connected between A and C. Now one more resistance is connected between A and C. This is of 2 ohm, and this is your point B, and 1 ohm is connected, and 8 ohm is connected between point B and C. So this is your point, this is your C point, and connect, here is the 8 ohm resistance. Okay, and now you again move from point B, and you will see that 6 ohm resistance is connected between point B and C. So this is your one more resistance, and it is connected between point B and C. This is of 6 ohm. Now as you know that you have to find the equivalent resistance of the given circuit is what? This 4 ohm and 2 ohm both are in parallel. So you can solve here 4 into 2 upon 4 plus 2. This is equal to 8 upon 6. This is equal to 4 upon 3. Okay, this is your 4 upon 3. Okay, and this is your point A, and this 8 ohm and 6 ohm both are also in parallel to each other. So 8 into 6 upon 8 plus 6 you can write, and 8 this is your 48 and this is your 14, and this is your 24 upon 7. Okay, and this is your 24 upon 7. Okay, and this is your point B. So you can write it is a series combination. So 4 upon 3 plus 24 upon 7, this is your answer. Okay.